Is it okay if you can call your friends to come in, WhatsApp them or Telegram them?
Boleh sir, boleh.
Okay, thanks. How many students are there? Akmal Azri left the meeting. One, two, three, four, 5, 6, 7, 8, 9. Yes? All right. Okay. Hello, everyone. Is it okay if you can turn on your camera? I just want to see your face. All right. Okay, I can see few faces. Okay, why is there still someone who didn't turn on their camera? Are you shy? Okay, let's wait another 4 minutes. While waiting, I just want to check your attendance first. Okay, so we have Danish Haziq, Akmal Azri, Amshar, Rushaidi, Asifan, Danish Haris, Firhan Darwish, Haziq, Alif, Amma, Amir Afif, Daniel Fitri, dan Danish Iqbal Zikri, Zaim, Ni Ahmad Amiruddin. Okay, students, I just want to ask you, have you finished your syllabus for Form 4?
Yes.
Yes sir.
Yes,
So
sir.
you already finished your syllabus for Form 4? Okay, all right. So when is your next school starts? When is your school going to start? I can't hear you. You guys are muting.
Probably the 2nd of January, I think.
Oh, the school is going to
Supposedly
start.
lah.
Okay, 2nd of January. Okay, I think we can start now. Oh, not yet. Okay, another 3 minutes. Okay. Right, just to let you know, I was also a student in SAS. My SPM was few years ago in 2013. So when in 2013, how old are you at the time?
8 years old.
How many years? What?
8.
8 years old. Oh, okay. So 2013. 2013, you are 8 years old. Okay. So I was in the Shamuddin sport house. If I'm not mistaken, my dorm when I was Form 1 is C4. um, a lot, a lot of things happened during the time. And then I continue my studies in University of Sheffield in UK. And then I studied there for 4 years. And then I graduated last year and here I am. But right now I'm doing my master's. Okay. So with us, joining us is my friend. Um, so this is Wise. He's my friend. So he's gonna be teaching you as well. So he will be helping me to teach you circular measure for today. Okay, so we have 1 minute left before we start. Okay, Ois, do you want to say anything before we start? Okay, maybe not yet from now. Okay, Ois, do you want to say anything before we start? Okay, he's actually adjusting few things. Ois, do you want to say anything before we start? Oh, sorry, we can't hear you. It's muting. Okay. I think you can start. I think there's an internet connection over there. All right. Okay, students, it's already 11 o'clock. Okay, I think we can start. All right. So my name is Kurnia. You can call me Mr. Kurnia. I'm also a teacher. Owais is also a teacher. But currently we're doing our masters. So we are happy for you to be here. And as you know, circular measure will be the first chapter of Form 5. Okay. So all right. I'm gonna pick a name. Okay. So Muhammad Shahmi, are you there? Muhammad Shahmi, are you there? Hello, Muhammad Shahmi.
Yes, sir.
Okay, Shahmi. So when you first hear the word circular measure, what do you think of?
Measuring circle shape.
Measuring circle. Okay, that is actually correct. Measuring the circle. Okay, that is correct. Sifan, when you first hear the word circular measure, what pops out in your mind?
Uh, I think it will involve a lot of formula.
It will involve a lot of formula.
Yes.
Okay, right. Okay, so throughout this lesson, okay, we will learn deeply about circle measure, and I will explain to you a lot of things about circle measure, and it helps you in your daily life. Okay, so don't worry, all your answers are actually, there's no wrong or right. I just want to know what you think of about circular measure. Okay. So before we start, I'm gonna let my friend here, Ois, to recall a few things, because by doing this chapter, it gonna relates a lot with parts of the circle, the things that you already learned in your Form 3, your Form 2. I hope that you remember, but if you don't, we will recall together. And of course, you already learned basic trigonometry, right? and also the Pythagoras theorem. I believe that you already learned this in your Form 2 and also Form 3. Don't worry, it's really simple, but we just want to test you. Okay, now, Wise, do you want to um, continue with the next session? I think we can't hear you because you're muting.
Okay, okay. Can you hear me now? I'm so sorry.
Yes, yes.
Okay. So can we go to the next slide? So you guys, you all remember these basic parts of the circle, right? Can you go to the next one? Okay. So we have made some slides over here. I will be asking like random people. So for example, I can ask Danish, can you name the first one, the purple one? So what part of the circle is that?
It's
So these are just
the radius.
is the radius, correct? So this is nothing very difficult. It's just like the very, very basic parts, just to like test you guys if you are like familiar with the parts of the circle. So who can answer the second one, the black shaded region? So what is that called?
Sector.
It's the sector. Okay, that's correct. Any volunteers for the third one? Again, the black shaded region. Amsia?
Segment.
That's the segment. Okay, that's correct. That's the segment. The next one? Arc. Okay, so you all are very familiar with this. That's an arc. What about this one? The yellow circle. So the black line, that's the tangent. Okay, that's correct. Okay. The next. Any volunteers for this one? Sorry, come again?
Chord.
Chord. Yes, that's right. That's the chord. So this is pretty basic, right? There's nothing difficult here. So we're just recalling the previous things. So what about the next one? Anyone?
Circumference.
Circumference. That's right. And then finally, everyone knows this one.
The diameter.
Right, the diameter.
All right, well done for those who can answer all of this. So you are actually correct. Radius, sector, segment, arc, tangent, chord, circumference, and also diameter. For those who didn't remember, take a picture, hurry up, just for you, for your own information. Okay, so we will continue with the next one, just to recall. Okay, Wise?
Okay, so basic trigonometry. How are you guys with trigonometry, by the way? I want some interaction from you guys. Do you find it difficult, or is it easy, or how? Anyone? Hello. Can you guys hear me? Or I'm not sure if my internet connection here is bad or.
No, I think they just try. I think you just have to pick a name.
Okay, okay. So you guys remember sine, cos, and tan, right? So these are just very basic trigonometric functions. So I don't know if you guys have already studied sine of an angle. Have you guys done that? Anyone? So for example, sine.
That's the basic.
Just the basic one, nothing too complicated. Like for example, you have an angle, so sine of that angle is what? So when you have if I can share my screen, just 1 second. Let me just share my screen here. Okay, can you guys see this?
I think I have to unshare this.
Oh, you have to unshare. Okay, so are you guys able to see this?
We cannot see your screen yet.
Cannot see my screen. Second. Let me try again. Okay, I'm gonna share. Okay. I think it should work now. Okay, can you guys see this now?
Yes.
Yes, sir.
Yes.
Okay. So what I'm asking you guys, okay, so if you have a right angle triangle, just like this. So this is your right angle triangle. So for example, if this is theta, let this be ABC. So do you guys remember what sine theta is?
Opposite over hypotenuse.
Yes, that's what I'm asking. So this should be,
Correct.
in terms of this triangle ABC,
CB over AC.
right, CB over AC. So can you answer for cos as well? Cos and tan.
Cos theta is AB over AC.
Okay, so the adjacent side over the hypotenuse. And finally, tan theta is
CB over AB.
right. So opposite side over the adjacent side. So that's AB. So just the very basic one. Let me. Konya, can you share the slides again? 1 second.
Yes.
Okay. Yeah.
Okay, so that is correct. So you have sine is equals to opposite over hypotenuse. Cos is adjacent over hypotenuse. Tan is opposite over adjacent. I believe that you already learned this in your form 3, right?
So Kato, I believe we also learned this in our high school.
Yeah.
Right? Mhm.
Okay. And the next one is?
Okay, so who is familiar with the Pythagoras theorem? This is even more basic than trigonometry, right? Everyone should be familiar with this. I don't think I need to make an annotation for this, right? So the hypotenuse squared is equal to the sum of the square of the other two sides. Everyone should be familiar with the Pythagoras theorem. So here a square, rather a and b are the other two sides. C is our hypotenuse. So c square is equal to a square plus b square. Is everyone okay with this?
Yes.
Yes.
Yes, sir.
Okay.
Okay, so I believe that all of you already recall a few things. For example, Pythagoras theorem, a squared plus b squared is equals to c squared. And then you already recall about the basic trigonometry, sine, cos, tan, and also the parts of the circle. So these are the few prior knowledge that is very important for this chapter. Okay, so this is where you're gonna start learn a new knowledge. So if you have any questions, please raise your hand, or you can use the raise hand tool like this. Yes, if you want to raise hands, or if I didn't realize that you are raising your hand, just let me know. You can unmute yourself. You can also stop me while during my presentation. It's okay because I do want some interaction from you guys. Okay, so let's start with the very new knowledge for today. So this is the circular measure. So in circular measure, we will normally hear the word radian. Okay, so what is actually radian? Okay, if you can see on the screen, it actually says 1 radian is the measure of an angle. It's a measure of an angle. So I believe everyone know what is an angle, right? Subtended at the center of the circle by an arc length is the same as the radius of the circle. Okay, so does anyone understand before that? Okay, I'm gonna ask Danish Haris, are you there?
Yes, I'm here, sir.
Kenapa sedih je? Why are you so sad?
Ah,
Okay, Danish Haris, do you understand
Yes.
by the word radian?
I think I do.
Okay, so
So
can you explain a bit about what you understand about radian?
a radian is the angle which is at the center of 2 radius from the center of a circle. Is it
From
correct?
the center of the circle to, okay, that is the radius. Okay, thank you, Danish. All right. Okay, for example, this is the circle, right? Okay, this is the circle, and this is your center. And I believe that all of you know what is arc. Okay, arc is okay, and this is arc. Is that true? That is arc. Okay. Before we draw the arc, we need to know the radius of the circle, and the radius is from the center to the end until it touches the circumference. However, what is radius? If you bring out this radius, if you bring out like this and bring out like this, it will become, this length is equals to the radius of the circle. And then if you bend it over, this arc is equivalent to the radius of the circle. Means that the arc length is equals to the radius of the circle. Is that clear? Means that your arc length is equals to the radius of the circle. And that is actually radian. Okay? And this radian, if you bring another radius, that angle is actually radian. Okay? That angle is actually radian. Is that clear? Okay?
Yeah.
All right. So in circular measure, we normally use radian instead of the degree. So whenever you see like a 60 degree or a 40 degree, you have to change it to radian. Okay. For example, from degree, if you have like a 60 degree, for example, you have something here, 60 degree. So if I want to convert it to radian, I have to times with pi over 180. So I have to times with pi over 180 in order to get radian. If I have something like a 2 radian and I want to convert into degree, so I have to times with 180 over pi. But you need to remember, in circular measure, normally we use radian instead of degree. Okay, is that clear? Any questions?
No.
All right. Okay. So now let's start with the first example. Okay. Convert 30 degree to radians in terms of pi. Okay. So I'll give you like 10 seconds to do this. It's really easy. Okay. 30 degree to radians in terms of pi. So what do you get for this? What do you get, students? Asif Khan, what do you get?
1/6 pi.
Oh, Nick, okay, thank you. 1/6 pi, that is correct. So you have a 30 degree, and if you want to change it into radian, so you have to times with pi over 180, and that's how you get 1/6 pi radian. Okay, is that clear?
Yeah.
Yes.
Okay, good job. Okay, for example, to convert 73.2 degree to radian. So what do you get for this answer? What do you get, students?
61/150 pi.
Yes, but since the question says convert into radians, you have to times it with pi because it doesn't say here in terms of pi. Okay, so you have to times the pi as well. That is correct. Good job. So 73.2 degree. Okay, you times with pi over 180. So you have to times the pi as well. So you will get 0.129 radian. Is that clear? Okay, students? Any questions? Any questions for that? No questions. Okay. All right. So next is I really want you to understand why do we have to times with pi over 180 if you want to convert from degree to radian. And from radian to degree, why do we have to times with 180 over pi? Okay. All right. So right now, one circumference, what is the value of the whole circle of the circumference? What is the value of the whole circle, students?
2 pi r.
Yes, that is correct. It is equivalent to 2 pi r. Okay. Okay. So we already know that for 1 radian, this is radius, and the radian, the arc length, is equivalent to the radius. The arc length is equivalent to the radius. So, therefore, for the number of arcs that we need, 1, 2, 3, 4, and so on, is equivalent to 2 pi arc length. So, this is the number of arc length that we need. Number of arcs is equivalent to 2 pi. Okay, so therefore, for a full rotation, how many degree in one circle? How many degree that we have?
160.
360.
Yes, 360 degree. So that is equivalent to 2 pi radian. Is that clear? Because the whole circle, the number of arcs that we need is 2 pi. And the whole full rotation is actually equals to 360 degree. Okay, so if we want to know how many radian, 1 radian, it is equivalent to 360 degree over 2 pi. So this is equivalent to how many? 180 over pi. That is how you get this. Is that clear now?
Can you please explain it again?
Yes, okay. So we know that the whole circle is 360 degree. Is that correct? For the
Yes.
whole one revolution is 360 degree. Okay, so we know that radian is where the arc length is equals to the length of the radius. Is that correct? So how many arc length do we need to complete the whole circle? We need 2 pi. So the arc length that we need to complete the whole circle is equivalent to 2 pi. So 2 pi is equivalent to 6.28. So we need 6.28 of radius to complete the whole circle. Is that clear? So in terms to get 1 radian is equivalent to, if you want to get the radian right, so it is 360 over 2 pi. So 360 over 2 pi is equivalent to 180 over pi. This is where I just want to explain to you how we're going to get 180 over pi. That's all. Okay? Is that clear?
Yes.
Yes. Okay. Any question? It's okay. Don't be shy. You can ask me any question like, why is it 2 pi? Because 360 divided by 2 is equivalent to 180. Okay? All right, no question. All right, next, arc length. Okay, so arc length is very important. So the arc length is denoted by S. So this normally, we call it arc length. Okay, so normally we put it as S. Okay, and the radius is R, and the central angle is theta radian. So normally arc length is equals to radius times with theta. Okay, Okay, if you want to get the arc length, you have to get the radius first and you have to get the angle. But you need to know and you need to remember that the angle is always in radian, not degree. Is that clear, students?
Yes.
Okay.
Yes.
The theta is always in radian, not degree. Okay, so let's start with the first example. A sector has a radius of 10 cm, an angle of 2 radian. Find its arc length. Okay, so tell me, what is the answer for this?
Five.
Sorry, what's the answer?
5.
5. Okay, so we already
So
know
that's
that
the
the
formula.
radius is equals to 10, right? Okay, it's a good try.
Mhm.
And then the angle is equivalent to
2 radian.
2 radian. So if we use the formula, S is equals to R theta. So we need to know the arc length. So arc length is actually S. Is that correct?
Yes.
S is equals to R theta. So R is 10, radian is 2. Therefore, your arc length is equivalent to 20 cm. Okay? Is that clear now?
Yes, sir.
Yes.
Okay. All right. Good job. So I just want you to understand how we're going to get S is equals to R theta. What is the meaning behind this step? Okay, we already know that arc length is equivalent to theta. We take the ratio of 2 pi because of the whole circle times with the circumference. The circumference is the whole circle. We already know that the whole circle, what is the value of circumference? What is the formula of the circumference?
2
Students?
pi r.
Yes, 2 pi r. So theta over 2 pi times with 2 pi r, and then that's how you get r theta. Just cancel the same, and then that's how you get r theta. Theta r or r theta. That's how you get the value of the r theta. Okay? Do you have any question? Why do we have this? Because in the circle, we need to know the angle. So we need to know the ratio of the angle. So this is theta, theta over 2 pi. And that's how you get r theta. You have to times with the circumference because you need to know the arc length. Why? Because that is also a ratio that you can do. Arc length over circumference is equivalent to 12 over 2 pi. Is that correct? Now, can you see it now? And then that's how you bring the circumference to the other side. So arc length is equivalent to theta over 2 pi times circumference. And we already know that circumference is equivalent to 2 pi r. Is that clear, students?
Yes.
Yes.
Okay. All right. So that is how you get arc length is equals to r theta. Okay. So I believe all of you already know how to get the arc length. Arc length is S equals to r theta, and you already know how to convert from degree to radian and from radian to degree. So, and we already briefed a little bit about the prior knowledge to this. So we have the next activity, the teamwork time. So we already divided you into groups. Okay, I just want to know, is there anyone here who doesn't have your name in this group? No one? All of you have your names here? Okay, so you are given 20 minutes to discuss among your group only because I just want to know what's how each of your group discuss among yourself. Please send me your working once you're done. So you are only given here you are only given about 15 minutes because we are running out of time. That's okay. 15 to 50 minutes only, not 20. 15 minutes to discuss. Please send your workings once you're done, and then there will be a presentation from every group. So, in every group, you just pick one. It doesn't have to be the group leader. So, the group leader will be the one in the red color. If there is no group leader here, just pick the second one. Okay, as long as you're in your group. Okay, all right. Okay, so the worksheet, I will give it to you now in Telegram. Is that okay?
Yes.
Okay.
Yes.
All right. So I'll give it to your worksheet in Telegram now. Hold on, yeah.
There's only going to be 3 questions, guys. So what you can do is you can split the work among yourselves. So like maybe 2 people can work on one question. And there are 6 of you, I believe, or there's 5 only. Okay, so maybe 2 people or one person can work on one question. 2 people can work on the next. So you guys can finish that in 15 minutes. They're not too complicated. If you're not able to understand, then or if you have some mistakes in the questions, then we will show how the questions are done. So you will be using your prior knowledge of Pythagoras theorem and arc length, the one that we just learned. So S is equal to R theta. You will be applying that, and you will be using your previous knowledge of Pythagoras theorem and this one, trigonometric functions, or just the basic trigonometry. Is that okay?
Yes.
All right. So there are 3 questions here. So I already sent here. So you can discuss with your friends in group. And we will start discuss at 11:45. Okay? Okay, students, just a reminder for you. For your first question, whenever you want to use your trigonometry, you have to convert your calculator to radian mode. Okay, so do you know how to convert to radian mode using your scientific calculator?
No.
No. Okay,
No.
so just take your scientific calculator, press mode, and mode, press mode 4 times. Do you see the word radian, R-A-D?
Yes.
Yes, and then press 2. And that's how you get your radian mode. Okay? Okay, so you have 5 minutes left. Okay, students, are you finished already? Have you finished? Yes, no?
Yes, but we are not sure with our answer.
That's okay. That's
Okay, that's okay. All right. So I think we don't have time, but at least we can do the first two questions first, and then worksheet 3 will be your homework. But I will give you the answer later. But we can discuss the first two questions first for today. Okay. So at least we have a homework for you to do. Since we don't have really have a time. Okay. All right. So can every group send your work or you can share you can share your screen, you can display your screen. Are you able to do that?
So you guys did it on paper, is it?
Or okay, since you do it on paper, right? Okay, can you take a picture and send it to me? You can send it to me to Telegram, just one from each group. only for question 1 and question 2 only. Okay. Okay, I'm waiting for your answers.
Maybe the group leader can send it to you.
Okay, the group leader, can you send me your work? Okay, Amshar Rushaidi already sent his. The rest of you? Okay, so I'll just put it here. Save. Amshar Rushaidi, this is only for question 1. The rest of you, can you please send me your work? Let's see, try. Okay, Amshar Rushaidi, is it okay if I share your work with your classmates?
Okay, sir.
Okay. All right, so I share your work with your classmate. Okay, so the first question I put here. Okay, so Amshar Rushaidi. Okay, the first you answered 1.6961. So from here, okay, yeah, okay. Okay, so from here you put from, wait a minute, 1.696. Okay, Amshar Rushaidi, can you explain a little bit about your work here?
So, I change the radian to the degree. So,
Okay.
divide pi over 1 group.
Okay.
Then, to confirm, say 97.174 by
Okay, how do you get 1.696 at the first place?
See, the question is actually asking you to show that it is 1.696,
Ah,
right?
yes, the question asks you to show 1.696.
Maybe you might have gotten confused. It's not given. The information is not given. That is what we want to show, that theta is equal to 1.696.
Okay, it's okay. I can help you with part 1, and then otherwise you can explain the part 2. Is that okay?
I'll share my can I share my screen quickly?
Okay,
I'll show the first and
Alright.
second part
Yeah.
of this question.
All right.
Okay. Let me just window. Okay. Can you guys see the screen?
Yes.
Yes.
Okay, let me just enlarge this for you. Okay, I think it's clear now. Okay, so the first thing, you see that we are supposed to show this theta is equal to 1.696. So first of all, that information is not given. You might have, maybe some of you might have gotten confused that, okay, this information is just given for you. That's not the case here. That is what we want to show, right? Okay, so how do you go about solving this question? So if I draw it over here, so you have a circle over here. You have QP over here, right? And then that is meeting at the center. So this angle they have given as theta. Okay. This is your P, Q, and O. Okay, so how do you go about solving this question? What you need to understand is, okay, we need to actually go here. It's lagging a little bit. Okay, you actually need to draw a perpendicular from here. Do you guys know that if you have a chord and if you have a perpendicular, what happens to that chord? Can anyone tell me? If you have a perpendicular from the center to a chord. Anybody?
Same length.
What's that?
Same length. Or 90 degree.
Okay, that's 90 degree, that's right. But it also splits the chord into halves. If you have a perpendicular from a chord, it's going to split it into two halves. So this is going to be 6 centimeter, this is going to be 6 centimeter. We have this as 8. So let me do that again. 8, and we have this as 8. This information is given. So what are we supposed to find? We are supposed to find the angle theta. So what is this angle? Half, right? Theta over 2. I'm sorry. So this is theta over 2. And the other one is also theta over 2. It's the same angle. Theta over 2. Okay? So we can deal with one of these. We can deal with one of these triangles and then just double to get the overall, the whole angle theta. Okay? So can anyone suggest how we can do this? So we have a right angle triangle over here, right? And we have two lengths over here. Okay, let me just redraw that triangle over here to make it easier and clearer. So we have this, this, and this, something like this, right?
Sine.
Yes, that's correct. This is B, let's say this is M. So this is PMO. We have this 90 degree. Just a second. Okay, 90 degree. This is our theta over 2. We don't know this one. And we have these lengths, 6 and 8. So we can use sine. Sine of the angle is what? What is sine of an angle? Anyone?
What's the formula, students?
Opposite over
Okay.
hypotenuse.
Opposite by, so we have to see this angle. The opposite angle is, so the opposite side is this 6, and the hypotenuse is 8. So you see in this equation, we have only one variable, which is theta, or theta over 2, either one. So we can find the value of theta over 2 over here. So how can we do that? You guys know how to use sine inverse in your calculators, right?
Yes.
Yes.
Okay. So what you can do is, you can simply, theta over 2 equals to sine inverse of, sorry. Okay, 6 over 8. So what is the answer? Theta over 2.
48.
Can someone give me sine inverse of 6 over 8?
What do you guys think?
48.590.
Okay, so 48.590.
590.
So you can find the value of theta. By the way, this is in degrees. We will need to convert this to radians in the end, but that's okay. We can keep this in degree for now. So theta will be equal to, you get the two other side. Can someone give me the answer? So 48.5903 times 2. Times 2, 97.18,
97.1.
right? 97.1806. So the last step is pretty easy. You just have to convert this into radians. How do you do that?
Times pi over 180.
Okay. So theta is equal to, can someone do the calculation for me? So whenever you want to convert from degree to radian, you're going to do times pi over, times 180 over pi. So this is going to be 97.1806 times. Is this
Times
correct?
pi over 180.
Pi over 180, right?
Times pi over 180.
My bad. So what is the answer for this? Pi over 180.
1.696.
Right. So that is how you show. And this is in radian. Radian. Okay. Is everyone clear with the concept?
Okay, students, do you have any question to Mr. Owais?
So may I ask if we use cosine rule that we learned at chapter 9 form 4,
Yeah,
boleh ke?
that
Kalau
also
kita
can,
pakai.
as long
You
as
can,
you use the
yes.
form, can get.
Okay.
You can use
Alright.
any one of them. So this bit is clear to everyone?
Yes, sir.
Yes, sir.
There was nothing too complicated here. All we did was made this perpendicular so that we were able to get a right angle triangle over here. This is our right angle triangle. And then we use basic trigonometry, which is sine of an angle. Finally, the last step was that we converted it into radian. There are multiple methods of doing this question. You don't have to follow this exact way, but if you're able to get the answer correct, then that's fine. Is that clear?
Yes, sir.
Okay.
Yes, sir.
All right. So let's come to the second bit. It's asking the perimeter of the shaded region. You guys remember perimeter, right? So this is our shaded region over here. So they are asking us this whole length. Okay. So how do you go about doing this? Let me just make another page over here. Just copy this one over here. Okay. So what we just found was theta, right? What was that? 1.696 radians. Okay. So can anyone tell me how can we find, okay, we already have the length of PQ, which is 12 centimeters. So we need to add that with this arc length, the bigger arc, right? The bigger arc PQ. So we just learned one formula. Arc length is equal to r theta. Is that right?
Yes, sir.
Arc length
Yes.
is equal to r theta. So we need to find the arc length of this region, PQ, the bigger arc. So how can we do that? So we need to know this angle for that, right? We need to know this angle for that. Oh, I cannot annotate over here. 1 second. Let me just draw one circle over here. Okay. All right. It's actually supposed to be straight. So we already have theta. So what is this one? Anyone? So what is the angle of a whole circle?
360.
360 degree, which is 2 pi, right? You just learned that 360 degree is equal to 2 pi. So my S is going to be what? We already have the radius. So theta. And theta in this case is not this theta, so I should actually not write theta over here. But this is just the general formula. You guys understand that, right? So theta in this case is actually going to be this bigger angle. So what is that? That is going to be 2 pi minus this angle, which was 1.696. Is this clear to everyone?
Yes.
Yes.
So 2 pi is the overall angle. You're subtracting this with the smaller angle, so you get this bigger angle. So that is your theta. There's no place to work here. Okay. So now it's just simple, right? There's only one variable. You just have to plug this in your calculator and it can give me the answer. So 8 times 2 pi minus 1.696. What do you get? Can someone give me the answer?
The 36.70.
Okay, so 36.7 centimeters. This is from here all the way until here, right? That is your S. So finally, can someone tell me how to do the perimeter?
2 pi r minus
So perimeter is going to be this length plus this length. That is your perimeter, right? So this is going to be 36.7
Plus 12.
12.
plus 12, that's right. Which is 48.7
8.7.
centimeters. So that is how you calculate the perimeter. Again, it's the same concept. We are just applying this formula, S is equal to R theta. The only difference is we're doing it for this bigger arc, so it might get a bit confusing. Normally, we do it for the smaller arc, and then we use the included angle, right? We're doing the same thing. We're using this bigger arc, and then we're using the included angle, which is this big angle over here. So in order to find that bigger angle, we did 2 pi minus the smaller angle. That's all we did over here. So we just use this formula. Is this clear to everyone?
Is that clear, students? Any question?
Yes.
Questions you can ask me.
Everyone clear?
Clear.
It's clear, right? You can go through these again.
Okay, if you want to take a picture, just let Mr. Wise know so that he can show a little bit for you. Hold it longer.
You guys want to take any pictures of this one? And like I said, guys, this is one method. If you can come up with another method, maybe using another concept of mathematics, that's completely fine, as long as you're getting the correct answer. So maybe some of you might have used another method. Maybe instead of using trigonometry, you might have used Pythagoras theorem. That's also okay.
Yeah.
Okay, is that okay?
Okay, sir.
All right. Okay. So does anyone finish with the second question? Wise, is it okay if I can share my screen?
Okay.
Does anyone knows how to do the second question?
Okay.
Okay, so I just want to ask for the first question, can anyone tell me why does ABC is equilateral? Syamuddin, are you there?
Because the angle is same.
Sorry, what is it, Amsha?
The angles are same.
How do you know the angles are the same?
It is same.
Yes, that is correct because the sides are equals to the radius of the circle. All of the sides of the triangle, all of the sides of the triangle is equal to the radius of the circle. See, here is the center and here is the end of the circumference. So this is equals to the radius of the circle. Here is also the center and this is the end of the circle. This is equals to the radius of the circle. This is the center and this is the end of the circumference. So this is also equals to the radius of the circle. Since all of the sides are the same, therefore it is equilateral. Is that clear, students?
Clear. Yes,
Yeah.
sir.
Okay. So now for part 2, okay, before we go to part 2, let's read the question together. The diagram shows two circles. Okay, so there are two circles. Center A and B. So we have two circles with both center A and B. Each of the radius is 10. So the radius is equals to 10. The point B lies on the circumference of the circle with center A. The two circles intersect at the point C and D. Okay, so the point E lies on the circumference of the circle center B. Okay, such that ABE is the diameter. Write down in terms of pi angle CBE. Okay, I want to ask you students, does anyone get for angle CBE? Don't be shy to tell me your answer. If it's wrong, that's okay. Does anyone get an answer for angle CBE? Okay, how about does anyone get 2 over 3 pi, the angle? 2 over 3 pi. No one?
Dapat sir.
Oh, you got. Okay, good job. All right. So write down in terms of pi angle CBE. Okay, so this is how you do it. Okay, for those who get it, can you share with your classmate how you get angle 2 over 3 pi? What is your first step?
First thing first, kan yang tu kan equilateral, so dia punya side 60 degree. And then ABE tu straight line, so nak dapat CBE punya degree, kita 180 minus 60 dapat 120. And then 120 times with pi over 180 dapat 2 over 3 pi.
Yes, that is correct. Good job. So, as I try to re-explain about what your friends did just now. Okay, we already know that this is actually a equilateral. So we already know for equilateral, all the sides are the same and the angles are the same. So if angles are the same, what is the angle over here, students?
60.
60 degree. So since this is a straight line, so we know that in a straight line, it is 180 degree. So in order to find the other angle, the adjacent angle here, so this is where you get it. So 180 minus 60 and you will get 120 degree. So in order to find the angle in terms of pi, you have to convert it into radian. So you already have the angle CBE. So 120 degree times with pi over 180 degree. And since we want the answer in terms of pi, and that's how you get 2 over 3 pi. Is that clear, students?
Yes.
Yes. Any question? Okay, so good job. So no question for that. All right, so find the perimeter of the shaded region. Okay, right now we want to find the perimeter of the shaded region. Okay, in order to find the perimeter, as Mr. Y said, so perimeter is the outer line here. So from arc CE, from the chord DE, chord DB, and also CB. Okay, find the perimeter of the shaded region. Okay, I want to ask you students, does anyone here in this class get 58.3? Does anyone get 58.3? Okay, that's all right. If no one gets 58.3, okay, this is how you do it. Okay, we already know that CBE, what is the angle of CBE, students? What is the angle of CBE?
120.
120.
Yes, but in radian it is 2 over 3 pi, because in circular measure we always use the radian. 2 over 3 pi. Okay, so if we already know the angle of 2 over 3 pi, can we get the arc length CE? How are we going to get the arc length CE, students?
By the formula.
By the formula, which is r theta. R theta. So what is the radius? The radius is equals to 10. And the theta is 2 over 3 pi. So make sure the theta is always in radian, not degree. So the length of CE is equivalent to 2 over 3 times pi times 10. So this is equivalent to 20.944. Okay, we already find the length of CE. Now we want to find the length of DE. Okay, for DE, do you have any idea how to find the length of DE? Because as what we learned just now with Mr. Owais, how to get the length of DE? What we're going to do? What do we have to do, students?
Divide by 2.
Yes, you just have to divide by 2 and therefore you will get a right angle triangle. So once you get a right angle triangle, here see, so this is a 90 degree. That is actually a 90 degree. And we already know that if this is this, you can see here, this is actually 120 degree. This is also 120 degree. Automatically, that this angle is also 120. If you half of that, that will be 60 degree. Is that clear, students? So if you convert 60 degree into radian, so 60 times with pi over 180, you will get 1 over 3 pi. Okay, is that clear? That is how you get that area. If you can't see, you can just write down here. So this is from here. So this angle, this is 1 over 3 pi. And you already know that BE is actually the radius. So this is actually B. Let's say this is M. So M, and this is also E. Okay, so you already know that BE is equivalent to the radius. So 10. So right now we want to get ME. Is that correct, students? Okay,
Yes.
so ME, how are you going to get the ME? So what do you have to do? What do you have to do next? How are we going to get ME? How are we going to get ME? Yes?
The sine rule.
Yes, using the sine basic trigonometry. So, sine 1 over 3 pi, okay, you have here, so right, ME over 10.
10.
So that's how you get your ME. So 10 sine 1 over 3 pi is equals to ME. So ME is equivalent to 1/3.
8.66.
Oh, you get 8.66. Okay, that is correct. 8.666. Okay. So what is the value of DE? If ME is equals to 8.666, DE is equivalent to? Can you calculate for me?
I say it's only 66, not 666.
Okay, 8.66. All right. So what is DE? If ME is equals to 8.66, DE is equivalent to?
17.32.
17.32.
Yes, 17.32. Okay, so you already have your CE, you already have your DE, and you already have your DB. How do you know what is the value of your DB? Because DB is equivalent to what, students?
The radius of the circle.
Yes, DB is equivalent to the radius of the circle. So we already know that perimeter is equivalent to DB plus CB plus arc CE plus DE. So you will get, sorry, this is DB. So DB is 10 plus 10 plus arc CE, which is you already calculate here. So 20.944 plus DE, you already calculated here, plus 17.32. So that's how you get 58.3. Is that clear, students?
Yes.
Yes.
Okay. All right. Any questions?
Sir, may I ask,
Yes.
basically what is the difference between kalau kita guna radian mode dengan degree mode semua tu?
Okay.
How is
For
it?
example, I want you to use your calculator, right? Okay. Right now, at your calculator, is there a word R or not?
Yes.
Okay, that is actually the radian mode. Okay, for example, write down pi over 3. Pi over 3, what do you get?
1/3 pi.
Yeah, 1 over 3 pi, what do you get? 1.047, right?
Yes.
Yes.
What, yeah.
And then
1.0.
sine answer. Sine answer, what do you get? Sine the answer, sine 1 over 3 pi, what do you get?
0.866.
0.866. Okay, that one, your calculator already converted into the radian mode. If you use the degree mode, it is in degree. For example, there is no radian at my calculator. My calculator, I already changed it to the degree mode. So pi over 3, I put sine. The answer will be different. Okay. Try now. I want you to change to your degree mode. Have you changed it to your degree mode in your calculator?
Yes.
Okay. So what do you get for sine 1 over 3 pi?
0.183.
0.018.
0.018, sorry.
Yes. So actually, it is a different value. Is that correct?
Yes.
Okay, so that's why whenever you came across a circular measure questions, make sure that you already change your calculator to radian mode. So it will help you and it will make your answers easier. Because if you don't change, you might be confused with the angle because the angles should always be in radian mode. Is that clear?
Yes, sir.
For example, like this, right? I have 120 degrees. Supposedly, I don't have to do 120. I can just put into radian mode. But since some of you just need some explanation to it, that's why I put 120. But basically, in this circular measure, we don't have to convert it if we already changed into radian mode. Okay, do you have any questions for that?
No, sir.
No. Okay.
Yes.
All right. Any last questions before we move on with the conclusion? No question? All right. Okay. So, some reflection and summary. Okay, I know some of you are like a little bit quiet, so I'm gonna pick a name. Alif, are you there, Alif?
Yes, sir.
Okay, Alif, can you tell me what you have learned today? What have you gained for today?
Uh, I learned
Hmm.
that if we have degree, we want to convert to radian.
Yeah.
We must times with pi over 180.
Yes, that is correct.
If you want to change back to degree, we must divide by 180 over pi.
Yes, that is correct. So again, as what your friend said, if you want to convert from degree to radian, you have to times with pi over 180. If you want to convert from radian to degree, you have to times with 180 over pi. Okay, thank you so much. Now I'm gonna pick a name. Helmi, are you there? Helmi? Helmi? Okay, Helmi is missing. Imran, are you there, Imran?
Yes.
Yes, Imran. Okay, what else that you have learned for today?
I learned that arc length equals to r theta.
Yes, that is correct. Arc length is oop, arc length is S is equals to R theta. S is equals to R theta. Okay, so I'm sure that all of you already know a few things, degree conversion, arc length. What else about scientific calculator? What do you have to do? Anyone? Any volunteers?
Make sure it is on radian mode.
Yes, if it's on radian mode, you don't have to use the degree radian conversion. But if you don't want to use the radian mode, you have to use the degree radian conversion. Okay, and make sure that in S equals to R theta, theta is always in radian. Okay, students. All right. Any questions? Okay, Mr. Owais, do you want to say anything?
Yes, sir. Yang circular measure ni saya dia keluar kat section C kan? Is it ke tak
Circular
agak?
measure. Yes, in SPM normally comes out in section C during my time, but I don't know SPM during your time how it goes because right now it might changes. So we see how the syllabus goes. Okay.
Oh,
All right.
okay.
All right. So I hope that you will do well in your revision and your SPM will be just around the corner. This will be your next year will be your final year in school, right?
Yes.
So
Yes.
I hope you
Yes.
best of luck. Be a good senior. Don't bully anyone. It is very, very a wrong thing to do. Make sure that you pray 5 times a day and do well in school. Do well in your studies. Okay? All right. So before that, I will unshare this and I might take a picture. Oh, hold on, yeah. Mr. Owais, do you want to say anything? No. Okay. All right. So can everyone turn on your camera? Is that okay? I just need to take a picture for our report. Okay. Can all of you turn on your camera? Okay, hold on. All right. Okay. Thank you so much, students. So thank you for coming and helping us. So I think that's all for today. Thank you so much. Bye bye. You can have a
Thank you,
short.
sir.
Thank you, sir.
Thank
Thank
you.
you,
Thank you,
sir.
sir.
Thank you,
Thank
Waalaikumsalam.
you.
Thank you,
Thank you,
sir.
sir.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.
Bye.
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 Waiting for. Hold on. Okay. All right. Is everything okay? Wait, I think I already, yes, I already record. Sorry. Okay. Sorry, otherwise I can't hear you.
Oh, I
Yeah.
wasn't muted again, I think.
Okay.
Okay.
Right. So I think that's all.
Mhm.
Maybe we can start the next thing next week.
Okay, sure. We'll discuss that.
Oh, do you know that for Euclidean geometry we have to do something?
What do we have for Euclidean geometry?
We have to do like do a presentation, and we
Oh,
have to
really?
pick a topic.
Oh, yes. I did see that. Yes. It's supposed to
Alright.
be any topic, right?
Do you have a group already, or
No, I don't have a group.
okay? We just do the same lah for
Yeah.
Euclidean
Sure.
geometry. Okay.
Is it group of two or
It could be 2 or 3.
two or three? Okay.
Hmm.
Sure.
Okay. All right. Okay. So that's all.
We're
Thank you
still
so
recording, I think.
much for helping.
We're still recording, right?
Oh yeah, it's the, oh yeah. I
So
can edit
we
this. I
can
can
just
edit
drop.
this.
We
All
can
right.
drop.
Okay. Thank you.
All right. Thanks a lot, man. It was a nice session actually.
Yes.
We
Yes.
went a little bit over time, but I think it's okay. Half
Yes.
an hour.
Yes.